Hello students, I am creating this video to show you one example of how to simplify expression involving radicals and exponents. And perhaps we are going to discuss one example on how to do rationalization to simplify any expressions. All right, these are the two topics that I was unable to cover during the exam one review. So let's try to see one example of each of these technique. All right. So here is the first example. Let's say we would like to simplify expression involving exponents and radicals. Suppose I give you this mathematical expression 3x to the power 4 square root of y divided by z to the power 5 entire thing to the power 3 multiplied by 6x square y to the power 2 divided by um, z to the power 5, or let's say z to the power 3, entire thing raised to the power 2, raised to the power negative 2. All right. Suppose we would like to simplify this expression involving exponents and radicals. Remember, we solve this type of problem in 4 simple steps, right? Step 1, convert outer negative exponent into positive exponent. So you observe if there is any negative outer exponent that we have. All right. If there is any negative outer exponent, my goal is to convert that outer exponent into positive outer exponent. Once that is done, I am going to distribute that outer exponent to every single factor of the base. I will then simplify the numbers and then I will multiply power of powers. And then I'll shift everything into the numerator. I will simplify all the powers involving the exponent sharing the same base. All right. So these are the topics that these are the steps that I'm going to apply on in order to solve this particular example. So let's try to solve it. Look, I am going to first convert that negative 2 power into positive 2 power. At the same time, I am going to rewrite that fancy notation, square root sign, in form of a numerical power. All right. So I am going to keep the first expression as is, and then to convert that negative exponent into positive exponent, I am going to switch the numerator and denominator of this expression. All right. So this is what I get. Now all the outer exponents are positive. It's time for us to convert, to distribute that outer exponent to every single factor of the base. Let's do that. I'm going to distribute this 3 power to every single factor of the base. So I'm going to get 3 to the 3. X4 will also get 3 power. Y to the 1 by 2 will also get 3 power. And then z to the 5 will also get 3 power. Okay. Same way, z cube will get 2 power. 6 will get 2 power. X square will get that 2 power. And y square will also get that 2 power. Okay. So far I have done 2 steps out of 4, right? I converted outer negative exponent into positive exponent, and then I distributed that outer exponent to every single factor of the base, no matter whether the base is in the numerator or in the denominator. All right. Now, third step, simplify numbers and multiply power of power. So I'm going to simplify the numbers first. I have 3 to the power 3, that is 27. 6 to the power 2, that is 36. So I simplified the numbers and I wrote them in the front. Now multiply power of power. I get x to the power 12, y to the power 3 by 2 over z to the power 15. And then I have z to the power 6, x to the power 4, and y to the power 4 as well. All right. Okay, now time to simplify these numbers further if possible, right? We know that we can cross out 9 from the top and the bottom. So this 27 over 36 is really 3 by 4. All right. Now shift everything into the numerator. I get x to the 12, y to the 3 by 2, z to the 6. These are the terms that were in the numerator. And then I'm going to shift all of this in the numerator. So z to the negative 15, x to the negative 4, y to the negative 4. All right. Now, if you have two exponents sharing the same base and they are related with multiplication sign, you need to add the powers. This is the rule we are going to use. Let's use it and let's simplify those powers. I get 3 by 4 x to the power 12 plus negative 4. This is literally 12 minus 4, right? Same way, y to the power 3 by 2 minus 4, and then z to the power 6 minus 15. All right. I simply need to simplify those numbers. All right. We already know 12 minus 4 is 8. So 3/4 x to the 8. We know how to handle rational and a complete number. Find the common denominator, make it visible under both terms, and then simplify the numerator. And this will be z to the negative 9. Right? I end up getting 3/4 x to the 8, y to the negative 5 over 2, z to the negative 9. Right? Now, if the question only says simplify rational expression, then you can stop here. This is perfectly fine to be accepted as a final answer. Right? If the question says write your final answer with all positive exponents, then in such case you will have to shift these two exponents into the denominator and make them positive, right? So again, this is what I need to do if question requires me to write the final answer with all positive exponents. Look at that. This is our final answer. Again, it's a very simple process, straightforward process. We did it in 4 simple steps. Convert any negative outer exponent into positive outer exponent. Distribute outer exponent to every single factor of the base. Simplify the numbers. Multiply power of powers. Shift everything in the numerator and then add the powers for the exponent sharing the same base. All right. So this is again one of the type of problem that we were unable to discuss during the exam 1 review. The second type of problem that we couldn't discuss was about rationalization. So let's recall this idea with one example as well. So let's say I give you this problem. Let's say rationalize and simplify. Suppose I give you 12 divided by square root of 7 minus 2 plus 5 square root 7. Suppose we would like to simplify this expression involving radicals. Obviously, our goal is very clear. We would like to, rationalize the denominator of that first term. And once it is being rationalized, we are going to add 5 square root 7 to it. All right. Let's recall how we solve it. All right. So again, in order to solve it, I'm going to first consider expression in the numerator 12 divided by square root of 7 minus 2. Our goal is very clear. We would like to rationalize this. We would like to get rid of that radical sign from the denominator. Let's do it. I'm going to multiply and divide this expression by the conjugate of the denominator. All right, conjugate of the denominator is square root 7 plus 2. All right, as you can see, I have factorization formula for difference of 2 square complete in the denominator, a minus b, a plus b. I can write this as a square minus b square. Let's do that. So I get 12 times square root of 7 plus 2 in the numerator, and denominator is going to be square root of 7 square minus 2 square. So we basically expanded this factors a minus b, a plus b as a square minus b square. As you see, they will give us an opportunity to get rid of radical symbol from the bottom. Square root 7 square is 7, 2 square is 4. Look at that. I get 12 square root 7 plus 2 divided by 7 minus 4. And this is indeed 12 times square root 7 plus 4 divided by 3. All right. Since we are going to add this expression with 5 square root 7, it will help if you simplify this further. I get 4 square root 7 plus 4. And let me also distribute this 4 over both terms. So I get 4 square root 7 plus 16. This is how I want you to interpret this simplification, first line and the last line. We have two ways to write down this entry. Either you write it in this way where the radical is in the denominator, or you can write exactly the same number in this form where there is no radical in the denominator. Remember the issue with radical having in the denominator. Radical entries, if it represent irrational numbers, then it will have infinite non-repeating tail, and when it shows up in the denominator of any expression, we realize that we have a problem there, right? So we better express this number in this format because there is nothing involving radicals in the denominator. Now I will go ahead and I will simplify this two-term expression. Now 12 over square root 7 minus 2 plus 5 square root 7, this is going to be, I'm going to replace that first term by its rationalization, 4 square root 7 plus 16, and then second term is still 5 square root 7, right? Now simplify the like terms. Look, I have 4 square root 7 plus 5 square root 7. Add them how you add the like terms. 4x plus 5x, how do we add them? We add them in a normal way, how we add 4 and 5, right? 4x plus 5x is 9x. For the same reason, 4 copy of square root 7 plus 5 copy of square root 7, they makes it 9 copy of square root 7. So I get 9 square root 7 plus 16. All right, so this is the number representing this expression. All right, so we obtain this by using rationalization technique. And again, the idea is pretty simple. Unfortunately, due to the time limitation, I was unable to discuss these two topics. I want you guys to try examples related to this from your paper homework assignment, from your quizzes, and from our class note. And if you have any difficulty, send me an email and I will be very happy to meet with you over Teams to discuss any of the topics that you feel it's tricky. All right, so this is all for this particular video. I hope all of you have a great rest of your weekend, and I will see you all on Monday in the exam room. Thank you so much, and all the best for your exam.